Hey class, this is Mr. Schmidt for our December 16th and 17th review. One class asked a couple questions for me to give examples. So this first example is of a projectile motion question. So I tried to come up with the most sophisticated type of projectile motion I could. It is at a height, it is at an angle, and we want to find its landing place. Okay, so let's map out our thinking process for how to do this. Okay, so our final answer is going to be dx. Okay, that's what we want to find. Okay, in order to do that, we're probably going to have to do our basic equation here. Okay, so that should look super familiar. Now, if we think about these points here, we know that that is 0 and a of x equals 0. So if that is true, then these two will equal 0. But that means we have to back up here and we have to solve for time. Okay, so if we have to solve for time, that probably means we're going to have to do this one. Okay, we have almost no zeros in this one. That's what makes this one a more sophisticated question than some of the other times we've seen it. Okay, so other things we know, acceleration and the y is going to be our negative 9.8. Okay, and then we're going to have to figure out both velocity in the x and velocity in the y. So we have to do this triangle to figure that out. Okay, so let's use this as our template. Okay, and start by finding these 2 points. Okay, so again, we had this triangle here, okay, where this was 15 meters per second, and we're going to have, okay, v in the y and v in the x. So this is going to equal 15 times the sine of 20 degrees, and this is going to equal 15 times the cosine of 20 degrees. Okay, all right, so let's get out a calculator here and find some of these answers. Okay, so we get our 2 numbers here. Okay, so now we can start filling in this right here. We can say our dy equals our initial height plus our initial velocity in the y, okay, times time plus 1/2 times negative 9.8 times time squared. Okay, now what was our final y displacement? We end up at 0y. We started off at 3, we end up at 0. So that's going to set us equal to 0, which is nice because now we have something that looks a lot like the quadratic formula. Okay, this is going to be negative 4.9 t squared 5.113 t 3 equals 0. Okay, so this is, we plug this into the quadratic calculator. We should get 2 values for t. One is negative, which is not possible, and the other one is 1.465, looks like, seconds. Okay, so that gives us our time. So now we've walked our way through. We've done this, we've done this. Now we're down to here. So now we can take our velocity in our x times our time, velocity in our x, which is going to be our 14.10 times our time, okay, and let's take a look at what we get here. All right, 14.1 times 1.465 equals 20.65 meters. Okay, So that is going to be how we could solve a more sophisticated two-dimensional motion problem. Okay. Notice it can go here. This is our positive t. This is our negative t. Negative t doesn't exist. That's why we looked at that. Okay. All right. So that's the first one. All right. So let's say our second question is we are pulling a block up a hill. So it's accelerating up the hill at this rate. Okay. It has friction. It's at an angle. It has mass, and we're going up the hill. So first step, let's do our force diagram here. So we're going to have force of gravity is going to be going down. Okay, perpendicular to the surface. Going to be my force normal. Okay, opposing motion and parallel to the surface is going to be my force of friction. Okay, so there is my diagram. We're going to break this up into different components eventually because we're going to call this direction X and this direction Y. Okay, so that tension is only acting in the X, friction is only acting in the X, normal force is only acting in the Y. So we only have to resolve one force, and it's already kind of defined, so we don't have to do multiple unknowns within one equation. Okay, so that's going to be our layout. But let's think for a minute about how we're going to solve this. Okay, so again, I like to start at the bottom here. I know I want to find tension, and tension is a force in the X. Okay, so I'm going to have to have tension, force of friction, plus the force of gravity in the X. Okay, so this is supposed to be force of friction. Okay, all right. So we know this one. We're looking for that one. We don't know this one yet. So how do we find the force of friction? Mu force normal. Okay, by the way, all of this is going to be equal to my acceleration in the X. Okay, so in order to find the force of friction, we have to use this. Okay, they don't give us the force normal yet, so we're going to have to do our sum of our forces in the Y equals our force normal plus our force of gravity in the Y. Okay, all of that is going to equal my acceleration in the Y, but that's the whole point. There's nothing accelerating through the board, so that is going to equal 0. Okay, all right, so we should be able to find this. We know that's 0, so that will be easier to find, which will give us this. Okay, then we can come down. That will give us these points, and then we can solve for this one. Okay, so now we have a roadmap of an equation where we'll know everything, and then everything should fall out. Okay, so one of the facts we're going to have to do here is that triangle we were talking about. Okay, so we had our force of gravity. Okay, and some of it's going to be in the X, and some of it is going to be in the Y. Okay, so we have to resolve those two. Remember, if that's 20 degrees, this is also 20 degrees. So we can say this is, whatever it is, force of gravity times, we're adjacent here, cosine of 20, and this is going to equal the force of gravity times, we're opposite of that angle, sine of 20. Okay, so now we can start doing some of these calculations, right? So this was our roadmap, and now this is going to be our plan of attack. All right, so first one we said, let's figure out what the force of gravity is. equals, that's going to be 49 newtons. Okay. All right. Next up, we can do our force of gravity times our cosine 20. Okay. And our force of gravity times sine of 20. Let's go ahead and get out a calculator and see what that is. Okay, so we did cosine gave us force in the y, sine gave us force in the x. Okay, so we plug that all into our calculator, that's what we get. All right, and then we can now go on to our next step here. Okay, so our force normal, which we don't know, is going to be our force gravity in the y equals 0. Okay, so if this is 46, that's 46. Okay, again, you can keep track of your positives and your negatives. I just like to keep track of it on my drawing. Okay, maybe not the best habit, that's how I do it. Okay, next up, now we can find our force of friction. Okay. Okay, and our mu was 0.1, 0.1 times 4.46 newtons equals 4.6 newtons. All right, so just like that, we're now at the bottom of the page here. Okay, so we set our sum of our forces in the x. It's going to be our tension, which is what we're looking for, plus our force of friction, which is what we just found, plus our force of gravity in the x, which is also found. It's all going to equal mass times acceleration in the x, which we already know. So that means we can plug in a lot of numbers here. Force of friction was 4.6 newtons. Force of gravity in the x, 16.76 newtons. Mass was 5 kilograms. Acceleration was 2 meters per second squared. All right, now we need to think about signs here, okay? So gravity is pulling this way, friction's pulling this way because acceleration is going that way. So we do need these to be, this to be opposite signs of these two, okay? All right, so now we can do some quick calculating here. Okay, so I brought those two together, 2 times 5. Okay, so now subtract 21 from each side. Okay, that is the force that would have to be on the string. Okay, so hopefully that got you prepared. You're well on your way taking a test now, and have a good vacation and a well-deserved break. And I will see everybody in January.